Ever wonder how Facebook tags your friends or how Netflix knows your next binge? It's not magic. It's artificial neural networks, or ANNs. Inspired by the human brain, ANNs use digital neurons to learn, adapt, and make decisions. From healthcare to entertainment, they're transforming our world in ways you might not even notice. In this video, we'll break down how ANNs work, why they matter, and where they're taking us. So buckle up, let's dive into the fascinating world of artificial neural networks. ANNs are already shaping our lives. When Siri answers your question or Spotify nails your music taste, that's an ANN at work. In healthcare, they detect cancer cells and predict patient outcomes. In finance, they detect fraud and power algorithmic trading. And in transportation, they help self-driving cars navigate the chaos of real-world roads. These networks analyze data, recognize patterns, and make decisions, faster and more accurately than ever before. And this is just the beginning. So how do ANNs actually work? At their core, they're made of digital neurons, simple units that mimic how our brain processes information. These neurons are arranged in layers and connected in a network. Feed them enough data, and they learn to recognize patterns and make predictions. The more data they see, the better they get, thanks to a process called machine learning. Let's take a closer look at what makes these networks tick. Think of an artificial neuron as a tiny decision maker. It takes inputs like pixels or words, assigns weights to them, and processes the result through an activation function. This function decides whether the neuron fires and passes information to the next layer. A single neuron is simple, but when you connect thousands of them, you get a powerful network. It's this web of neurons that allows ANNs to learn and adapt. And it all starts with how they process information. Picture an ANN like a multi-layered cake. The input layer takes in raw data, like image pixels or text. Hidden layers transform that data, extracting features and patterns. The output layer delivers the final result, like identifying a face or translating a sentence. Each layer adds complexity, allowing the network to understand data in deeper ways. That's how ANNs turn raw input into smart decisions. Training an ANN is like teaching a child to recognize cats. You show it labeled examples, cat, not a cat, and it learns from its mistakes. It adjusts the weights between neurons to improve accuracy. This process is powered by backpropagation, a key algorithm that fine-tunes the network. The more data it sees, the smarter it gets. And that's how ANNs learn, through repetition, feedback, and lots of data. Let's say we train an ANN to recognize cats in photos. It starts by analyzing pixels, then hidden layers detect features, like fur, ears, or whiskers. Weights determine which features matter most. At first, it guesses randomly, but with training, it gets better. Eventually, it can tell a cat from a dog with impressive accuracy. This simple task shows how ANNs learn to make complex decisions. The journey began in 1957 with the perceptron, created by Frank Rosenblatt. It could learn simple patterns and sparked early excitement about AI, but it had limitations. It couldn't solve complex problems. Criticism and lack of progress led to the first AI winter. Still, the idea of machines that learn had taken root. In the 1980s, backpropagation changed everything. It allowed multi-layered networks to learn from their mistakes. Like a teacher correcting a student, it gave feedback to improve performance. Combined with better computers, this breakthrough reignited interest in ANNs. The stage was set for a revolution. The 2000s brought a data explosion, thanks to the internet and digital devices. With more data and powerful GPUs, deep learning took off. Deep networks with many layers began outperforming humans in tasks like image recognition. Geoffrey Hinton's 2012 ImageNet win proved deep learning's potential. Today, ANs power self-driving cars, virtual assistants, and even medical breakthroughs, and we're only scratching the surface of what they can do. We've made huge strides in narrow AI, systems that excel at specific tasks. But the real dream? Artificial general intelligence, machines that think like us. Some believe scaling up neural networks could get us there. Others say we're missing key human traits like common sense and creativity. The road to AGI is long and uncertain, but full of possibility. Artificial neural networks are quietly transforming how we diagnose and treat diseases. From spotting early signs of cancer in scans, to detecting diabetic retinopathy in retinal images, and predicting heart attack risks. ANs are also revolutionizing drug discovery. They analyze massive data sets to find promising compounds faster and cheaper. The result? Faster diagnoses, personalized treatments, and life-saving breakthroughs. Remember the last time you traveled to a foreign country and struggled to decipher a menu or ask for directions? Yeah, those moments can be pretty frustrating, but hey, those days of frantic phrasebook flipping might soon be a distant memory thanks to the magic of machine translation powered by artificial neural networks. Traditional translation software relied on rule-based systems, painstakingly programmed with grammatical rules and vocabulary. While functional, these systems often produced clunky and sometimes inaccurate translations, especially for languages with complex grammar and idioms. Enter Neural Machine Translation, or NMT, a real game-changer. It leverages the power of artificial neural networks to learn the nuances of language and generate more natural-sounding translations. By training on massive data sets of parallel text, that is, the same text in multiple languages, NMT systems can learn to represent the meaning of words and phrases in a way that captures subtle differences in context and tone. This allows them to produce translations that are not only more accurate, but also more fluent and human-like. The impact of NMT is already being felt around the world, breaking down language barriers and fostering cross-cultural communication. From instantly translating websites and documents, to facilitating real-time conversations through apps like Google Translate, artificial neural networks are making the world a smaller, more connected place, one translated word at a time. Imagine a world where traffic jams are a thing of the past, where car accidents are rare occurrences, and where commuting is no longer a dreaded chore, but an opportunity to relax or catch up on work. Sounds pretty great, right? Well, this is the future that self-driving cars powered by artificial neural networks promise to deliver. At the heart of autonomous driving lies the challenge of perception, teaching a car to see and understand its surroundings. And this is exactly where artificial neural networks excel. Using a suite of sensors including cameras, LiDAR, and radar, self-driving cars collect vast amounts of data about their environment, from the position of other vehicles and pedestrians to the layout of roads and the presence of obstacles. This data is then fed into powerful artificial neural networks that have been trained to identify objects, anticipate their movements, and make split-second decisions. These networks learn to recognize traffic lights, interpret road signs, track pedestrians, and predict the behavior of other drivers, all in real time. The development of self-driving cars is still ongoing, with companies like Tesla, Waymo, and Cruise pushing the boundaries of what's possible. While challenges remain, such as navigating complex weather conditions and ensuring ethical decision-making in critical situations, the potential benefits are enormous. Increased safety, reduced congestion, and improved accessibility for people who are unable to drive themselves. The world of finance, with its constant fluctuations and complex data sets, might seem like an unlikely playground for artificial neural networks. But actually, ANs are rapidly transforming the financial landscape, from predicting stock market trends to detecting fraud and assessing risk. Imagine trying to predict the stock market, a notoriously volatile and unpredictable beast. Human traders rely on a combination of experience, intuition, and analysis of market indicators. But artificial neural networks can process vast amounts of financial data, From historical stock prices and trading volumes to news articles and social media sentiment, to identify patterns and make predictions with remarkable accuracy. Hedge funds and investment firms are already using AI-powered trading algorithms to make investment decisions, often outperforming human traders in terms of speed and profitability. But the applications of AI in finance extend far beyond trading. Banks are using them to detect fraudulent transactions, identify patterns of money laundering, and assess credit risk with greater accuracy. By automating tasks, reducing human error, and providing insights that were previously hidden, artificial neural networks are revolutionizing the financial industry, making it more efficient, data-driven, and potentially more profitable for those who embrace their power. Have you ever wondered how Netflix seems to know exactly what shows you'll love, or how Amazon manages to recommend products you didn't even know you needed? Well, the answer, in many cases, lies in the power of artificial neural networks to personalize our digital experiences. Recommendation systems, which are pretty much everywhere in our online lives, rely heavily on AIs to analyze our past behavior, preferences, and even demographics to predict what we might enjoy next. By tracking what we watch, read, listen to, and buy, these systems build a detailed profile of our tastes and preferences. This data is then fed into AIs that have been trained on massive datasets of user behavior. These networks learn to identify patterns and make connections that would be nearly impossible for humans to spot, allowing them to predict what we might want to watch, read, listen to, or buy next. The result? A more personalized and engaging digital experience. From suggesting movies and TV shows, to recommending products and curating news feeds, AIs are shaping the way we consume information and interact with the digital world, making our online journeys more tailored to our individual tastes and preferences. The applications of artificial neural networks go way beyond the usual suspects like healthcare, language processing, transportation, finance, and personalized recommendations. From optimizing energy grids to creating stunning works of art, AIs are pushing the boundaries of what's possible across countless fields. In the energy sector, AIs are being used to optimize the efficiency of power grids, predict energy consumption patterns, and integrate renewable energy sources into existing infrastructure. By analyzing weather patterns, energy demand, and grid capacity, AIs can help balance supply and demand, reduce waste, and make our energy systems more sustainable. In manufacturing and robotics, AIs are powering a new generation of intelligent robots that can handle complex tasks with greater precision and adaptability. These robots are able to learn from experience, adapt to changing environments, and even collaborate with humans in shared workspaces. And in the creative arts, AIs are being used to generate music, compose poetry, and even create stunning visual art. While some folks might question whether machines can truly be creative, these AI-generated works challenge our ideas of art and creativity, blurring the lines between human and machine imagination. For all their incredible abilities, artificial neural networks harbor a perplexing secret. Their decision-making process is often a mystery, even to their creators. Imagine teaching a child to ride a bike. You can show them how to balance, pedal, and steer, but eventually something just clicks in their brain, and they get it. You can't quite explain how they learned, but hey, they're riding. AIs are kinda similar. We feed them data, adjust their weights, and train them to perform tasks. They achieve impressive results, sometimes even surpassing human capabilities, but often, we can't pinpoint exactly how they arrive at their conclusions. This lack of transparency has earned AIs the nickname black boxes. Think about a facial recognition system. It can identify your face with remarkable accuracy, but can you explain precisely which features it uses to make that identification? Is it the distance between your eyes, the shape of your nose, or maybe some subtle combination of features we haven't even considered? The answer is often unclear. This black box problem poses a significant challenge. It's like having a brilliant but tight-lipped advisor. You might trust their judgment, but wouldn't you feel more confident if you actually understood their reasoning? This lack of transparency raises real concerns, especially in sensitive applications like healthcare, finance, and criminal justice. So, part of the challenge in understanding artificial neural networks, or ANNs, really stems from our tendency to anthropomorphize, that is, to project human-like thinking onto them. We often assume that because they can perform tasks that require intelligence in humans, well, they must be thinking and reasoning just like we do. But honestly, this is often far from the truth. ANNs, unlike humans, don't have common sense, intuition, or even a deep understanding of the world around them. What they do excel at is identifying patterns and making statistical inferences based on the data they've been trained on. Their knowledge, though it might seem vast, is often shallow and very context-dependent. For example, consider an ANN trained to identify images of birds. It might do a fantastic job distinguishing between different species based on visual features, but it wouldn't understand that birds can fly, or sing, or build nests. It doesn't grasp the concept of a bird as a living creature with its own behaviors and ecological role. This fundamental difference in how ANNs and humans process information makes it, well, pretty challenging to interpret their decision-making processes. Their thoughts, if we can even call them that, are encoded in this intricate web of weights and connections within their hidden layers. It's a kind of language that's often completely alien to our own ways of thinking. Despite these challenges, researchers are coming up with some really ingenious methods to peek inside the black box of ANNs and shed light on how they make decisions. One approach is to visualize the features that networks use to make predictions. So imagine showing an ANN trained to recognize cats a picture of a fluffy feline. Researchers can actually use techniques to highlight the areas of the image the network focuses on, like the pointy ears, the whiskers, or the shape of the eyes. This gives us valuable insights into which features the network thinks are important for identifying a cat. Another promising approach is to design ANN architectures that are more interpretable. Instead of relying on these deep, complex networks with millions of connections, researchers are exploring simpler, more transparent models that are just easier to understand. And sure, these models might sacrifice a bit of accuracy for greater interpretability, but that trade-off can be really valuable, especially in situations where understanding the decision-making process is absolutely critical. The quest to understand ANNs is kind of like trying to decipher an ancient language. It's a complex and ongoing process, but every new insight brings us a little closer to bridging the gap between human and artificial intelligence. And that, in turn, helps foster trust and collaboration between these two very different forms of intelligence. As artificial neural networks become part of daily life, the need for explainability is more crucial than ever. That's where explainable AI, or XAI, comes in, making AI systems more understandable and trustworthy. Whether it's a doctor or a judge, users need to know how AI reaches its decisions. XAI helps bridge the trust gap by revealing the reasoning behind AI outputs. It's still early days, but XAI could be key to building responsible, trustworthy AI for the future. The ethics of artificial thought, navigating the moral maze. As AI grows smarter, it faces real-world dilemmas, like a self-driving car choosing between passenger safety or a pedestrian's life. These aren't just hypotheticals anymore. Bias in AI is a major concern. Systems can reflect and even amplify societal inequalities. Solving this takes collaboration, developers, policymakers, and the public working together. We need clear ethical guidelines to ensure AI benefits everyone. When machines learn too well, job displacement fears. As machines take on tasks once reserved for humans, fears of job loss are growing. From self-checkouts to factory robots, automation is already reshaping industries, and it's moving into complex fields like transport, medicine, and finance. But history shows tech often creates new jobs as it replaces old ones. The key is adaptation, through education, retraining, and lifelong learning. One of the biggest challenges in building fair AI is biased data. Neural networks learn from the data we give them, bias in, bias out. For example, if resumes mostly show men in leadership, AI may unfairly favor male candidates. In criminal justice, biased data can lead to unjust outcomes and reinforce inequality. The solution? Use diverse representative data and audit AI systems for fairness. We've journeyed together through the intricate workings of artificial neural networks, those digital minds inspired by the very essence of our own brains. We've marveled at their ability to learn from mountains of data, to recognize patterns that elude human perception, to make predictions that shape our choices, and to perform tasks that once seemed unimaginable for a machine. From diagnosing diseases with superhuman accuracy, to translating languages in the blink of an eye, from guiding self-driving cars through bustling city streets to personalizing our digital experiences, ANs are no longer a futuristic fantasy. They're woven into the fabric of our daily lives, quietly revolutionizing industries, expanding our understanding of intelligence itself, and offering a glimpse into a future brimming with possibilities. But the rise of artificial neural networks is not merely about technological advancement. It's about the profound impact these technologies have on our lives, our work, and our very understanding of what it means to be human in an age where intelligence takes on new forms. As we've seen, ANs present us with both incredible opportunities and complex challenges. They have the potential to solve some of humanity's most pressing problems, but they also raise ethical concerns that demand careful consideration and responsible development. The future of artificial neural networks is not preordained. It's a future we're actively shaping through the choices we make today. Will we harness the power of ANs to create a world where healthcare is more accessible, transportation is safer and more efficient, and technology empowers individuals and communities? Or will we succumb to the pitfalls of biased algorithms, job displacement, and the erosion of privacy? The answers lie not in the algorithms themselves, but in our collective wisdom, our ethical responsibility, and our shared commitment to shaping a future where technology serves humanity rather than the other way around. This requires ongoing dialogue between AI developers, policymakers, ethicists, and the public. We need to establish clear ethical guidelines for AI development, ensuring that these technologies are designed and deployed in a way that aligns with our values and aspirations. We need to address the societal impacts of AI, investing in education, retraining, and social safety nets to ensure that everyone benefits from these advancements. Most importantly, we need to remember that artificial neural networks, for all their sophistication, are tools. They're extensions of our own ingenuity, reflecting both our brilliance and our flaws. The responsibility lies with us, the creators and users of these technologies, to ensure that they're used for good, that they promote fairness and equality, and that they contribute to a brighter future for all. The journey into the world of artificial neural networks is just beginning. As we delve deeper into the mysteries of the human brain and translate its principles into algorithms, who knows what incredible feats of intelligence we might unlock. Imagine a world where ANs help us unravel the complexities of climate change, developing innovative solutions to mitigate its impact and create a more sustainable future. Imagine a world where personalized medicine powered by ANs eradicates diseases that have plagued humanity for centuries. Imagine a world where AI tutors provide personalized education to every child, regardless of their background or location, unlocking their full potential and fostering a more equitable society. These are just a few glimpses into the extraordinary possibilities that lie ahead. As we stand at the precipice of a new era of intelligence, one where humans and machines collaborate in ways we're only beginning to imagine, let us proceed with both audacity and humility, with a deep sense of responsibility for the future we're creating, and with an unwavering commitment to using these powerful tools to build a brighter, more intelligent tomorrow for all of humanity.